So our observations with the James Webb Space Telescope were able to confirm the discovery of this exoplanet, LHS 475b.
It was quite an event actually for this first particular observation in our program. So typically the way things work is we know when the observation is scheduled and you'll get an email within about 24 hours of the observation being completed telling you that the data are available on the MAST archive. And so once we got the email, we dove in, we downloaded the data, and we quickly processed it using the custom software tools that we had previously written. And within a matter of probably an hour, maybe 90 minutes, we had produced the first light curve of this planet. And I just turned to Jake and I shouted, "Hey, we found it!" And then we just kind of high-fived and we celebrated. And it's like, yeah, this is a planet. This is actually a rocky planet. It was a really exciting moment.
One of the really exciting things about our discovery and our first results with JWST is just this demonstration of how sensitive the instruments are, how capable it is for observing precise observations of small rocky planets. And so it paves a pathway that's twists and turns, and ultimate end goals are a bit uncertain, but it's sort of a sure path towards learning something very interesting.
The instrument and the telescope as a whole wasn't specifically designed to answer the question of are we alone? But that doesn't mean we shouldn't make that attempt. It's going to take a lot of time and effort. And the first thing that we'll need to do is actually find rocky planets that have atmospheres. And from there, we can continue the search.
There are no images of the planets themselves. We're not spatially resolving them. So all the information is sort of buried within one sort of pixel, if you will. And so it's really taking a look at that and using techniques such as spectroscopy to study the composition of gases. And so since atmospheres are made of gases, and gases interact with light in very specific known ways, we can sort of sniff the presence of certain molecules from afar and get an understanding of the composition of an atmosphere. And at the same time, this leads us to looking for signs of life in the atmospheres of planets. Ultimately, these so-called biosignatures are remotely detectable signs of life, and often they're thought of to be gases that are in the atmosphere that can be detected from afar using spectroscopic methods.
All of this can be traced back to Christmas Day. If you remember, that was the day in which JWST launched. And that for me was the best Christmas present ever. And now that we have the data in hand and that we're able to play with it, every day feels like Christmas. It is just so magical playing with this data to see the wavelength coverage, the precision, the unexpected discoveries that we have. It's really exciting time for me as an astronomer and for someone who has been waiting over a decade to use JWST. It's really a new wave of exoplanet science, and I'm glad that we're here to ride that wave.